In this lecture, we will study the magnetic properties of materials, that is diamagnetism, paramagnetism, ferromagnetism, and so on. So, there is a very small experiment, although it should be done very carefully because a small variation in geometry or non-symmetry may lead to erroneous results. So let us say we take magnet in this form where the one pole of magnet is little pointed. So as you know, at the pointed edge, the flux density will be higher. So the field lines will be converging like this. So in this way, you see that the field lines are more dense on the uh, sharp edge. So if I suspend a material, this material should be very symmetric, otherwise there will be erroneous displacements which we do not want. So if I put a material in this field, then we will find that most of the materials will be repelled from the sharp edge, that is the material will try to go away from the higher flux density. So if it is repulsion, then it will show that the material is diamagnetic. In some materials there will be slight attraction towards the higher field. So slight attraction means it will be paramagnetic. And if there is a very high force of attraction, then it will be ferromagnetic. So this small experiment shows us that materials have different behavior towards magnetic field. Now this diamagnetism exists in every material. The only difference is that it gets overwhelmed by either paramagnetism or ferromagnetism or ferrimagnetism. So although it exists in every material, but it is not seen in special magnetic materials. It is normally seen in other materials, and most of the materials are diamagnetic. Even wood is also diamagnetic. So aluminum is also diamagnetic. So now we need to discuss the reasons of various properties of these magnetic materials. Although I should point out that we are trying to understand this thing with classical theory, but all explanations will be incorrect because all these effects can only be explained by the quantum mechanics theory only. So we will be dealing with theories which we know that they are not 100% accurate, but they will help us in understanding things. And on a macro scale, they will show us the reasoning of such kind of behavior of materials. So in this way, we are going to discuss the theories which we know that these are incomplete, but since we do not want to go to quantum mechanics, then we will just uh, learn through classical theories only. So let us see the reason of diamagnetism. So why does it occur? So you know that according to classical model of atom, the electrons are spinning around the nucleus, and since any charge which is orbiting and spinning, it will have an equivalent current, and it implies that it will have equivalent magnetic dipole. Now most of the materials have all those dipoles due to electron spin and orbital motions which are balanced. So ultimately there is no resultant magnetization either because of spin or orbital magnetic moment. But when we place them in an external field, now there is an induction, and because of Lenz's law, that induction will be in the opposite direction. So this causes the repulsion in the above experiment. So you see that a material which is having balanced moments when placed in a field will have induced dipoles or magnetic moments, and those induced magnetic moments will be opposing because of Lenz's law. So in this way, we will find that those materials will be repelling the magnetic field in which they are put. Now, this effect is not depending on temperature, because nothing in this explanation is showing any item which is depending on the temperature. These are already balanced, and this we are trying to put from external agency, so nothing is depending on temperature. So diamagnetism is more or less unaffected by temperature. So this explains the diamagnetic properties of material. Now in the next lecture we will see the paramagnetic properties of material. If you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join our Telegram group whose link is given in the description of this video. Thank you.